Hi, this is Mr. Heineman from Evergreen High School. This is for my Algebra 1 classes. This is Standard 3.2, Creating Linear Inequalities. So when it comes to linear inequalities and linear equations are related. They're similar. Linear inequalities look like linear equations, but they have an inequality symbol instead of an equal sign. So the symbols are just the same ones we used in solving inequalities: greater than, less than, greater than or equal to, less than or equal to, in order. And we represent them the same way. We don't always use tables. We'll use tables sometimes to graph. But when we graph linear inequalities, there's two changes to the way we graph. Because a linear equation would have a solid line as a graph. Linear inequalities, the line may be solid or dashed depending on what type of inequality, and then we shade on one side or the other of the line. And that's the main differences between linear inequalities and linear equations. So solutions of linear inequalities are like solutions of linear equations. They're points, but in this case it makes the inequality true. So what that means for graphing is that the points for an inequality will appear on the graph as what we call a half plane, which really means there's a line that provides a boundary and then shading on one side or the other. And that will encompass all of the solutions for a linear inequality. It looks a little bit different than just a linear equation, because linear equation is just going to have a line, no shading, and a linear inequality is going to have the line that may be solid or dashed depending on the inequality, and it may be or it's going to have shading on one side or the other. So a solution is always going to be in the shading area or the half plane of a linear inequality. If the inequality is an equal to, then it would have a solid line, and if there's a solid line, then we would count the line as solutions. So if a point was on the line, it would be considered a solution for a solid line, but not for a dashed line. And then of course any solution inside of the shaded area would be considered a solution. So I'm going to go over here, and we're looking at the point -3, 4. And so when I plot -3, 4, it's right here, not in the shaded area. So that must not be a solution, because the point's not in the shaded area. It's that simple. And so when I'm looking at solutions of linear inequalities, if it's in the shaded area or on a solid line, it's a solution. If it's on the dashed line or simply not in the shaded area, then it's not a solution. So when it comes to graphing, first thing we should be able to do is match up graphs with their inequalities. And most of the time in these sorts of questions, they're going to only ask you about the line and shading, or they're going to ask you about slope and intercept. And we've really looked at the slope and intercept really in linear equations. So these two focus mainly on shading and the line. So when we take a look at this graph, we notice that the line is dashed and that the shading is above the line. So we should make note of that, dashed line. And then up here we have the shading above. And so what we're going to do is look at these inequalities, because the only difference in all of these inequalities is the inequality symbol. The slope and intercept are exactly the same, so we're not even considering those. We're just looking at the inequality symbol. And I know that a dashed line means that it's not equal to. So it couldn't be B and it couldn't be D because those both are equal to. It has to be either A or C. And then I know with the shading above that that means it's greater than, so it couldn't be C, it must be A, because the line is dashed, meaning not equal to, and it's shaded above, meaning greater than. Over here, similarly, we have another line that is dashed, and then we have shading below this time. So again, dashed line means not equal to. We can eliminate the two equal to possibilities. And the shading below means less than, so it's not this greater than. It must be A on this one as well, for y is less than 2x minus 6. So I'm always looking at graphs, and when I'm graphing, I'm looking at the line, whether it's dashed or solid, and the shading, whether it's above or below. So when it comes to graphing inequalities, like graphing equations, we're going to find 2 points. And we're going to use the inequality for that, like we did with graphing equations. What that means is that in slope-intercept form, we use the y-intercept and then the slope to find a second point. So the y-intercept will be 1 point, use slope to get a second point, and that's how we find the 2 points. For standard form, we find both the intercepts, so set x or y to 0 and then solve. And once we find each of those, then whatever 2 points we find, then we're going to draw a boundary line that's based on the symbol. And then this is the difference between the not equal to and equal to. So not equal to is always a dashed line, and equal to will always be a solid line. That way, you can see if the line represents solutions or not. Then we shade on one side of the other, or one side of the line based on the symbol again. This time it's the greater than, less than. So greater than should be above, and less than will be below. So the whole process, find 2 points, draw the line, then shade, in a nutshell. And now we'll see that in action in the next problem. So here we have an inequality in slope-intercept form. So first thing I'm going to notice, here's the y-intercept. It is -4. And then the slope here is 3. So my 2 points that I'm going to use are -4 on the y-axis for the y-intercept, and then I'm going to go up 3 and over 1 to find my second point. So this is 3 over 1. And then I look at my inequality symbol, and I notice it's a simple greater than. So because it's a simple greater than, not equal to, when I draw my line, I'm going to make it a dashed line. And it's a dashed line because it's not equal to. And because it's greater than, I'm going to shade above the line. And so this is the complete graph of the inequality. The dashed line for not equal to, and the shaded area above for greater than. So we're going to get a chance to see a graph of a linear inequality in standard form, but we're going to first write that inequality from this story, because we should also be able to do that. So when we look at our problem, we see that we're selling small bows for $3 each. That sounds like a rate of change. And large bows for $5. So another rate of change. And we want to earn at least $60 a week. And it's important to not just note the $60, but also the phrase at least. Because we're going to write this in, it looks like standard form. We have 2 rates of change and a total. So we know it's going to be standard form. That's 3x plus 5y. X is small bows, and y is representing large bows. So the total is the sum of the two, and that's going to be related to 60, and we want to earn at least 60, which means 60 should be the lowest we have. And if 60 is the lowest we have, then certainly we want this to be greater than 60, but because we say at least 60, 60 could be a possibility, so we'd say equal to as well. So our whole linear inequality is 3x plus 5y is greater than or equal to 60. So now that we have this, we can go on and actually graph it on a set of axes. And graphing a standard form inequality, like graphing a standard form equation, has to do with finding intercepts. So I'm going to set x equal to 0 first to get rid of the x term. And then we're just going to focus on the 5y equals 60, because I want to figure out what y equals. In this case it's 12, so that I'm treating it kind of like an equation right now, because I want to see what the y-intercept is going to be. So I found it, it's 12. I do the same thing for x. When y is 0, 3x equals 60, divide by 3, so x equals 20. And then I can plot that point. And now I go back to my inequality and I look at this symbol right here. And I notice first that it's an equal to, meaning my line is going to be solid, so I can draw my solid line in. And then I notice it's also greater than, which means I'm going to shade above this line. And so this is the complete graph of this inequality, because it's got a solid line representing the equal to, and a shaded area above representing the greater than. So this is it for graphing inequalities and working with inequalities. We did a lot of this in equations already. It's just a matter of remembering that the line can be solid or dashed depending on the inequality, and remembering that you're shading one side or the other depending on the inequality. If you have any doubt about what side you should shade, you can always try a point. I could try this point right here. It's an easy point to work with. That's 0, 0. I could plug it in to see if that point makes the inequality true. 0 plus 0 greater than 60. Is 0 greater than 60? No, so I shade the other side. So that's it for graphing and working with linear inequalities.